What you're looking at here, it isn't just a new building. We are witnessing the rebirth of one of Hong Kong's most prestigious pieces of real estate, Lot Number 1, the legendary site of the old Excelsior Hotel, totally reimagined. This is the story of One Causeway Bay.
The central challenge here was just immense. How do you even begin to build a next-generation icon on a site that's packed with history, all while you're surrounded by a living, breathing city that, literally never stops? I mean, just look at this transformation. On one side, you have a beloved landmark, a piece of history, and on the other, it's evolution. This was never about just replacing something. It was about infusing that historic soul with next-generation engineering to create something completely new.
So let's really set the scene. You're building a 32-story commercial tower right in the heart of Causeway Bay. You've got the World Trade Center on one side, and on the other, a row of residential buildings from the 1960s, all sitting on very, very sensitive foundations. The stakes, they just couldn't be higher.
This map really shows you the scale of that challenge. Just 2 meters, that's it. That is the tiny amount of space we had to work with, right next to those older buildings. This wasn't just construction. This was like performing urban surgery in the heart of one of the world's densest districts with absolutely zero margin for error. Let's start with the challenges that were right there in plain sight. I'm talking about the problems that could have literally brought the city to a halt if we didn't get them exactly right. First up, the Chee On Bridge. Now, this isn't just any bridge. It's a 50-year-old piece of infrastructure that acts as a vital artery for the whole community. Shutting it down for the 2 years of construction? Yeah, that just wasn't an option. Period. So our solution had to be completely seamless. First, we drilled these massive steel H-piles deep into the bedrock for unparalleled stability. Then, we installed a custom steel frame, but with a twist, 8 computer-controlled hydraulic jacks. This amazing system allowed us to transfer the bridge's entire weight, all while monitoring every tiny movement in real time, 24/7. And the result of all that tech? Absolutely incredible. When we transferred the entire load of that bridge, it moved less than 2 millimeters. That's thinner than a couple of credit cards stacked together. Total continuity. We kept a vital part of this city open for 2 full years with zero disruption. But the visible challenges, they were really only half the story. On a site this complex, the toughest problems are often the ones you can't even see. So now, we're going to go underground, where a silent revolution in engineering was about to happen. Because down there, we had another monster lurking, the old hotel's foundation. We're talking about a massive 3-meter-thick slab of heavily reinforced concrete. So how on earth do you break through that right next to fragile old buildings without shaking them to pieces? While the traditional method, using a powerful vibrating hammer to break up the concrete, that would have been a total disaster. It's incredibly loud, it creates these massive vibrations, and it's super slow. We needed a whole new approach. Our answer was an innovation we call the Core-bide Method. And honestly, it's one of those ideas that's just brilliantly simple. We took a standard core bit and we welded on these incredibly tough tungsten carbide tips. So instead of hammering, this new hybrid bit could simply grind its way through the concrete. It was a total game changer.
And the difference it made? It was night and day. See, innovation should be felt, not heard. The Core-bide Method silenced the noise, but the huge win was this. It slashed vibrations by a massive 75%. That was absolutely crucial for protecting our neighbors. Turns out, excellence can be quiet.
But maybe the biggest win of all was for the environment. Because our method didn't need these huge diesel-guzzling air compressors. We saved an unbelievable 860,000 liters of diesel. To put that in perspective, that's a carbon reduction equivalent to taking over 460 cars off the road for an entire year. Now, any engineer will tell you this. No matter how well you plan, the ground always holds surprises. This next part is all about resilience. It's about how we adapted and optimized everything in real time. So, as we were digging, we were using these 3D laser scanners to create an incredibly detailed map of the site. And that's when it revealed something our first surveys missed. The bedrock was actually much higher than anyone expected in a few key spots.
Now, a surprise like that could have caused major delays on a normal project. But here's the cool part.
This brought the whole project to a fork in the road. Now, the standard engineering handbook, the conservative choice, says, when in doubt, pilot. You just drive hundreds of concrete columns deep down to the bedrock. It's safe, for sure. But it meant months of delays, tons of noise, and a huge carbon footprint. The team, though, they saw a bolder path, a single, massive concrete raft that would just sit on top of this mixed ground. It was way faster, cheaper, and greener, but only if they could prove it was absolutely safe.
And this is where the story really pivots from just building something to pure engineering art. They weren't going to guess, they were going to use data to prove mathematically that the bolder path was actually the better path.
This quote, right here, became their mission statement. It wasn't just about choosing a different option. It was a declaration. They weren't just going to follow the textbook. They were going to use hard data to write a whole new chapter. They didn't just guess. They modeled the soil structure interaction down to the millimeter. Using this incredibly detailed finite element method analysis, they basically created a digital twin of the site, simulating exactly how the raft would behave on those different rock levels. And they proved,
Instead of seeing a problem, our team saw an opportunity. We didn't just react, we optimized.
we went right back to the drawing board and adapted our foundation design on the fly. By making the new footing just a little bit thinner where the rock was higher, we turned that potential delay into a 3-week time saving on rock excavation. That's a true benchmark for data-driven efficiency. All of that problem solving, the visible, the invisible, and the unforeseen, that was the critical groundwork. It laid the foundation for a truly high-performance superstructure, which is what we all see standing there today. So what does all this complex engineering actually mean for the people inside? Well, it means performance. We engineered out all the clutter, even removing an entire row of columns to deliver what you see right here, the most prestigious, totally column-free sea views in the entire city. So the challenge became all about speed. How do you keep up the momentum on a really tight schedule while being absolutely certain of the building's strength at every single stage? Well, the key was building smarter, not harder. They knew they had to move beyond the traditional methods and embrace technology that could give them something absolutely priceless: certainty, in real time. So to know exactly when the concrete was strong enough for the next floor to be built on top of it, they embedded hundreds of tiny electrical sensors directly into the structure itself. These little sensors monitored the concrete's temperature, which is directly linked to its strength, and fed that live structural health data right to the team's fingertips. And this was a genuine first, a really big deal for the whole industry. This project became the very first in Hong Kong to get official approval for this sensor technology. And this wasn't just, innovation for its own sake. It was about achieving empirical certainty through data. And the results of all that certainty? An incredibly aggressive, yet completely safe 5-day floor cycle. Think about that. A brand new floor was completed every 5 days. This just proved that the marriage of traditional structural logic and modern monitoring is the key. You don't just build faster, you build smarter. So when you take all of these innovations and you put them together, from that carbide drill bit all the way to the real-time sensors, they start to form a blueprint for the future. So what's the lasting impact of this whole approach? Well, sustainability wasn't just some buzzword they added on at the end. It was engineered into the project from day one. They used top-tier, platinum-certified green concrete, rebar made from over 90% recycled steel, and they saved tons of material thanks to that wind analysis and the more efficient foundation design. So here it is, the final icon. It's more than just a building, right? It's a testament to resilience, to precision, and to a deep commitment to engineering a smarter, more sustainable future for Hong Kong. It takes turning problems into opportunities. It takes choosing innovation over tradition. And it takes a relentless focus on the human experience. This is the future. This is One Causeway Bay.